So I wanted to talk about solving literal equations. It's pretty much solving equations where you don't just get a single answer, you get a bunch of relationships as an answer. So if I want to solve this equation for y, it's currently in standard form, and if I want to solve it for y, I would be putting in slope-intercept form. So I wanted to kind of mention that this is how I would convert from standard form to slope-intercept form. So I'm trying to solve for y. So if I were evaluating, I would plug in, I would substitute in, and the very first thing I would do is look at PEMDAS or GEMDAS grouping, exponents, multiplication, division, addition, subtraction. So I would notice that the first thing I would do on my list would be to multiply. Then I would subtract whatever this value is from this thing. So I need to get rid of both the multiplication and this addition subtraction thing that's happening. I only care about things that are on the same side of the equal sign. So this 8 I can ignore. Now, you could do them in any order, but it's easier if you do them backwards PEMDAS, if you get rid of the addition subtraction first, because if you divide first, if I divided 2 by 3, it doesn't go in evenly, so I'd have a fraction there, or a decimal. And I usually want to wait until the very end in order for me to get a fraction or a decimal answer. So the very first thing I'm going to get rid of is this term right here. And the y is being subtracted from this 2x, but the 2x itself is actually a positive number. It's this y that is a negative number. This negative actually goes with the y term. So if I'm thinking about what math is happening with this 2x, what is this 2x doing to this y? It's a positive 2x, so really this number is adding to whatever the y value is. So the opposite of this positive 2x, if I'm trying to get rid of it, would be to make a zero pair, and the opposite of a positive 2 is a negative 2x. Now, because I'm not just trying to solve for x, I'm trying to move the entire term, I want to bring the x with it. If I look on this side, 8 doesn't have an x, so I'm not going to write it directly underneath it. I could, but I'm going to kind of write it to the side. That way I kind of tell my brain that they don't go together. They're not like terms. This has an x and that one does not. So because they're not like terms, I'm going to leave them a little space. So as I said before, this negative goes with the y. It's in front of the 3y, so it stays with that 3y. So I'm going to bring that whole term down. We did not use it. And these aren't like terms. So what would I do if they're not like terms? Well, I just wouldn't add them together. I'm going to leave them as two separate terms. Since they're not alike, I'm not going to add them together. I'm just going to leave them separate. And this is where I would tell you math grammar. There is such a thing. Math grammar says I should write all of my variables first in terms of higher powers. So this x is larger because there's at least one variable there, and 8 has no variables. So I'm going to go ahead and write this first. So I'm going to write negative 2x, and this 8 is a positive, so I'm going to write plus 8. Then I would say, well, have I solved for y yet? Is y all by itself? And the answer is no. It has a negative 3 that's being multiplied. So the opposite of multiplying by a negative 3 is to divide, and a lot of students are tempted to stop after they divide those two items. But whenever you are multiplying or dividing, you have to divide or multiply everything in the entire equation. So what I do to not forget is I go ahead and draw a line under every single term I can find. And then I will divide, and I will go ahead and put that negative 3 under all of those. So since I took the time to draw the line, I'm less likely to forget to divide everything by the negative 3. Now if you notice, not much cancels here, so I'm going to end up with fractions as my answer, but that's okay. Negative 3 divided by negative 3 is 1, so I end up with just 1y equal to a negative divided by a negative. They're opposites. They cancel each other out. If I multiply and divide by negative, it's like saying not. The 2/3 is not positive. Well, if it's not positive, right, it gets confusing when you have two negatives on there. So we want to simplify it and say if it's not negative, it should be a positive 2/3. So we're canceling that out. Also, if you've ever seen that baby face, it might help you remember how to multiply or divide. So most people don't have problems with a positive divided by a positive. It's a positive. But there are issues if I have negatives. So to make the baby face, I write two negatives with a plus underneath it like that. And then I draw, and I will use a separate color. And draw a circle around them. And then I do this. So that is the face that helps. So whatever you're doing, you cover up the two things you have. So right now I have a negative divided by a negative, so if I cover the negative up and the negative up, if you notice, I end up with a positive. Right? Negative divided by negative is a positive. So that helps you there. That's why my answer here is positive. If you had this one, for instance, you see over here, I have a positive 8 but a negative 3. So I'm going to go ahead and cover up my positive for the positive 8 and a negative for the negative 3, and that tells me what my answer should be negative. So I'm going to go ahead and write minus 8/3. And I've now taken this equation in standard form and solved it for y, so now it's actually in slope-intercept form, where my slope is 2/3, my rise over run, 2/3, and my y-intercept would be a negative 8/3. It's my b. So the next one, I want to solve for x. And if I think about it, if I were to have numbers in here, the first thing I would do is x plus y, because both of those are being divided by 3, so I kind of need to know what both of those numbers are together first. Then I would divide by 3. So this is kind of the first thing I want to get rid of. If I try to move the y is being divided by 3, so I would have to subtract y/3, and that would be dealing with fractions, which is not fun. So the first thing I'm going to do is to get rid of the 3. So all of this is being divided by 3. So the opposite of dividing by 3 would be to multiply by 3. So I'm going to multiply both sides by 3. I'm going to multiply everything, all terms in the problem. Since both of these, because of this line, are being divided by 3, I multiplied both of those by 3 just once. So the multiplying by 3 and the dividing by 3, it's like taking a step forward to take a step back. If I multiply by 3 and then go ahead and divide by 3, I didn't really go anywhere. So those two cancel out, leaving me just x plus y equals, and then 5 times 3 is 15. So I always ask, is x by itself? No, it has a plus y. So the opposite of that would be to subtract y from both sides. And 15 doesn't have a y, so I'm going to write it off to the side. And then just like before, I want good math grammar. So this y, I'm actually going to write it first. This became a 0. It's a 0 pair. Just like this was a 0 pair. I have x is equal to, I write my y first, so I'm actually going to write negative y, because it's a minus y, plus 15. And I've now solved this one for x. For part C, this is how you would convert from slope-intercept form, which is what it's currently in, to standard form, which is where I have a number all by itself on the right side. So when I solve for b, I'm going to have a number all by itself. B is just a constant. It's just a number. No variables. Normally. So my first step, and this is an easy one, b is being added with this mx term. So I'm going to go ahead and subtract mx from both sides. And then I'm going to write y minus mx is equal to b. And I could be done here. That could be one of my answers. If I want it in standard form, though, alphabet-wise, I need my x's to be written first and then my y's. Standard form is alphabetical. Math grammar says usually if all of the exponents are the same, you want to write them alphabetically in order. So this x would actually come first. So I would actually write a minus mx plus y equals b. And since my x term would be first, positive or negative, it's negative here, so that negative stays with the x. Y is positive, so that stays over here. This is in standard form. It doesn't look like it, but x, some number x plus some number times y is equal to a constant all by itself. So this would be the same kind of way that you would solve going from one to the other. Thanks for watching. Hope this helped.